These are the notes for 5.2 part 1, and what we're going to be doing today is multiplying polynomials. So in our last notes we were adding and subtracting them. Now we're going to be multiplying, which is a little more complicated, but we'll start out with some simple ones. So pause if you need to get this written down. And I'm going to go ahead and start. So on this first example here, we are multiplying a monomial by a monomial. So each of these two guys that we're multiplying here, they don't have multiple terms. They're each just one term, and this makes it really easy. So what you're going to do when you multiply these is first just multiply the coefficients. So negative 8 times 5 is negative 40. And then work your way through the exponents and the variables. So on this one, we got x to the 4 times x to the 3. And remember, we're multiplying, so we add those exponents up. So that's x to the 7. 4 plus 3 is 7. And then on our last term, we've got y to the 7 times y squared. So that's y to the 9 because we add up the 7 and the 2. And that's it. We're done simplifying because there are no other like terms. All right, on our second example down here, you are going to be multiplying again two monomials. So this one's pretty much the same. So first what you're going to do is just go ahead and multiply the coefficients of each. So in this one we've got a negative times a negative, so that's a positive. Negative 3 times negative 4 is positive 12. And then same thing, go through your variables and just multiply them. Remember to add your exponents up. So if you want to, pause this and try it on your own, and then you can see what the answer is in a second. So we are going to multiply a to the 5 times a squared, and that's a to the 7, because we added up those exponents. And then let's multiply b, which is like b to the 1 times b to the 5, so that's b to the 6, because 1 plus 5 is 6. And then last, we will do c to the 6 times c to the 8, and that will be c to the 14, because 8 plus 6 is 14. That's it. So those are kind of the end of the really easy ones. Those are just multiplying a monomial by a monomial. Now we're going to go into some where we're multiplying a monomial by a binomial. So one term multiplied by something with two terms. So here's our examples. Pause if you need to write these down. So this is something that you guys have been doing. All we're going to do here is distribute. We're going to be doing a lot of distributing today. So on this first one, we need to make sure that this 2t out here, it has to get multiplied to both the terms in here, the 3t and the negative 5. So what we're going to do is let's first multiply the 2t times 3t. So just like we were doing, we're going to multiply the coefficients first. 2 times 3 is 6. And then worry about the variables. So t times t is t squared. Remember, you can think of that as having a 1 and that as having a 1. So the 2t got multiplied to the first term. He's done. But we still need to multiply the 2t to the second term, which is negative 5. So again, we're multiplying the coefficients. The coefficients are 2 and negative 5, and 2 times negative 5 is negative 10. And then we have the t on the 2. He just gets to kind of come along. There's no t on the 5 to combine him with, so he just gets to come along. So our answer is 6t squared minus 10t. So we're going to do the same thing over here. We're going to multiply 3a squared b. He has to get multiplied to both of these terms inside the parentheses, the a squared and the negative b squared. Remember, you can think of this first b as having a power of 1. And then this b squared in the parentheses has a coefficient of negative 1. You can't see it, just says minus b squared, but that means it has a coefficient of negative 1. So just keep that in mind if that helps you. So let's go ahead and start distributing. We need to multiply 3a squared b times a squared. So remember, there's also kind of a 1 in front of here. So we can multiply the coefficients. 3 times 1 is 3. And then I'm multiplying a squared by a squared, so that's a to the 4, because 2 plus 2 is 4. And then this b has no b to combine with in this first term, so it's going to be b right there. And then let's go ahead and distribute 3a squared b times negative b squared. So we multiply the coefficients. 3 times negative 1 is negative 3. The a squared on this outside one has no a to combine with here, so it just stays a squared. And then b times b squared is b to the 3, because I added up the 1 and the 2 on the exponents. So hopefully that was also not too bad. That is just distributing. So we're going to do 3 more examples, and they're going to get progressively longer because we are going to be multiplying a polynomial by a polynomial, and they're each going to have more than one term. So we're going to start with multiplying a binomial with 2 terms by a binomial. And there's lots of different ways that people like to remember how to do this. So I'm going to try and show you all of them, and you guys can pick which way you like the best. So the way that I honestly kind of like to do this is it has the least graphic organizers and everything. I just keep in mind that every term in the first factor, so the y squared and the negative 5, needs to be multiplied to each of the terms in the other factor. So I just start with the first term over here, y squared, and I say, all right, he's got to be multiplied to both those guys in the other parentheses. So y needs to be multiplied to 2y to the 3. So that's going to be 2y to the 5. Then the y squared also has to get multiplied to the other term in those other parentheses. So we're going to do y squared times 4, and that's just 4y squared. So now this y squared is done. He's been multiplied to everything in the other set of parentheses. Now we need to multiply this negative 5 to everything in the other set of parentheses. So what you might want to do now is start doing these little loops that I'm drawing to show when I'm multiplying things. You might want to draw it below the parentheses so you have somewhere new to write. So I'm going to do negative 5 times positive 2y, and that's negative 10y. And now that negative 5 just needs to be multiplied to one more guy in the second set of parentheses, and that's the positive 4. So negative 5 times positive 4 is negative 20. Now, the only other thing you'd want to do is check to make sure you don't have any like terms that you can combine, and I don't see any like terms in this polynomial. Y to the 5, y squared, y, and a term with no y's at all, negative 20. So you are done. Now, let me show you some other ways that people like to do this. So one way you can do this is there's an acronym called FOIL. So let me rewrite this problem down. Y squared minus 5 times 2y to the 3 plus 4. So some people like to remember this acronym FOIL. It stands for first, outer, inner, pretend that dot's not there, and last. First, outer, inner, last, FOIL. So what this stands for is the order in which you multiply things, although honestly it doesn't matter which order you multiply them in. You could do off, last, inner, outer, first. You could do it backwards. It doesn't matter. So what it means is that for the first, you're going to multiply the first term in each binomial. First times first. So y squared times 2y to the 3 is 2y to the 5th. Outer means you're going to multiply the outer term towards the outside in each binomial. So outer to outer. So that is y squared times 4, so that's 4y squared. And then inner means the inner term in each one, so the two that are closest to the inside of those parentheses. So negative 5 times positive 2y to the 3, that's negative 10y to the 3. And then finally, last means the last term in each set, so that is negative 5 times positive 4, and that's negative 20. Again, check for like terms. I don't see any, so that's it. Wait, how did I get a different answer there? Oh, on this first one, we should have had 10y to the 3 right there. Whoops, sorry about that. All right, and then, okay, here's the problem. This FOIL thing only works if you're multiplying a binomial times a binomial. 2 terms times another 2 terms. That's why I don't like FOIL. Almost everyone uses it. That's how I learned it when I was in school. I don't like it. So I'm going to show you a grid method that will always work, and I'm just going to wait and show it to you on the next one we're going to do, because I think that on a multiplying a binomial by a binomial, it's almost kind of easier. I think it's easiest just to do it this first way. Just make sure each term in the first one gets multiplied by each term in the second set. But we're going to start getting a lot bigger problems, so that's is where I'm going to use a grid method, and I'll show you that on the next one. All right, so on this problem, you can be writing it down as I'm talking here. So we're going to be multiplying a binomial, p plus 2, times a trinomial, p to the 4 minus 2p to the 3 plus 3. So if you want, you can do this the same way that I was first doing that last problem. You can make sure that the p gets multiplied to all three, and then the 2 gets multiplied to all three. Sometimes that can get a little messy and hard to remember where you were, so let me show you a grid method that will also work. So whenever you're multiplying two polynomials, you can always use this grid method. It doesn't matter how many terms are in each of the polynomials you're multiplying. So here's how the grid method works. Take one of your polynomials, I'll do the p plus 2, and you're going to write each term going down the side of a grid. So p and 2. So then what we're going to do is, let me get some lines here. We're going to write at the top of the grid all the terms in the other polynomial. So in my other polynomial, I've got a p to the 4, a negative 2p to the 3, and a positive 3. So these are going to be what makes up my grid here, and this grid will help us make sure that each term gets multiplied by each other term in both polynomials. All right, so now what we do is we just fill in this grid by multiplying the two terms that meet at each square in the grid. So for example, at this first square right here, we're going to be multiplying p times p to the 4, so that is p to the 5. In this second one, we're going to be multiplying, and let me use a highlighter really quick to show you where I'm getting these from. So in this box right here, I'm going to be multiplying p times negative 2p to the 3. I'm going to be multiplying this times this because those are the two guys that meet in that box. Let me get rid of that highlighter. All right, so I'm going to be multiplying p times negative 2p to the 3. So that is going to be negative 2p to the 4th because this one has a 1, and 1 plus 3 is 4. In this last grid on the top, I'm going to be multiplying p, this one, times 3, and so that's 3p. And now we've got 3 more things to fill in on this grid. So let me switch colors here. I'll use purple. On the bottom, so this one is where the 2 and p to the 4 meet. So this is 2p to the 4. I got those from right there and right there. Oops. I'm not going to get rid of that circle. All right, and then in this next one, I'm multiplying negative 2p to the 3 times positive 2. So negative 2 times 2 is negative 4, and then we have that p to the 3 hanging out. And then in my last box, I have 2 times 3, and that is 6. So everything that turned out on the inside of that grid, all these terms, those are going to be part of my polynomial answer. So I'm just going to write all of those in order, and I'm going to add them up unless they're negative, in which case I'll subtract them. So I've got p to the 5 minus 2p to the 4th plus 2p to the 4th. I'm kind of trying to work in order here from greatest to least power of p, minus 4p to the 3 plus 3p plus 6. And then the only thing we need to do is make sure that we don't have any like terms we can combine. I do see something. I've got negative 2p to the 4th plus 2p to the 4th, so that's just 0p to the 4th. So those kind of cancel each other out. So we are left with p to the 5 minus 4p to the 3 plus 3p plus 6, everything else. So if you're not getting that box method, we can talk about it in class too. Sometimes it's a thing that's kind of easier to show visually. We're going to do one more example, and it's one where the box method really helps because we're going to multiply a trinomial times a trinomial. So get those written down, and I'm going to go ahead and start setting up my box here. So I'm going to put each of these three terms along the side of my box. Make sure to include a negative if it's negative, like this -4 right here. And then along the top, for the columns, we're going to put all the terms in the other set of parentheses. So I've got -2x squared, 3x, and 6. So those are my three columns. And this box method, remember, it's ensuring that every term in the first set of parentheses gets multiplied by every term in the second set of parentheses. All right, so let's do it. Let's multiply these. So I've got here in this first box 5x to the 3 times -2x squared. So that's -10x to the 5. -2 times 5 is -10. And for the x to the 5, I did 2 plus 3. The powers of x added up. All right, next box. I've got 5x to the 3 times 3x. So that's 15x to the 4. 3 plus 1 is 4. In our last box on the top, we've got 5x to the 3 times 6. So that is 30x to the 3. 6 times 5 is 30. The x to the 3 is just hanging out. Second row, we've got x times -2x squared. So that's -2 x to the 3, because x times x squared is x to the 3. Second box, we've got x times 3x. That's just 3x squared. Remember, this has a 1 in front of it, so I did kind of like 1 times 3 to get that 3. Last box, we have 1x times 6, so that's just 6x. And then this last row down here, we've got -4 times -2x squared. Negative times negative is a positive 8x squared. Second box, we've got -4 times positive 3x, so that's -12x. And then in our last box, we have -4 times positive 6, so that's -24. Oh, don't know why that turned yellow. All right, so remember when we write our answer out, we're only going to include these numbers that were inside the grid. We're not including the numbers that we put on the outside to multiply. So let's start writing these out and then see if we have any like terms that we can combine and get rid of. So I've got -10x to the 5 plus 15x to the 4 minus 2x to the 3 plus 30x to the 3 let's see, plus 3x squared plus 8x squared plus 6x minus 12x plus 24. I'm running out of room. And if you can combine some of those before you write them down, that's fine. If you can see in the grid that you can combine some terms, go ahead and do it. So let's see. Let's check here. X to the 5. I only have one term with an x to the 5, so I've got -10x to the 5. I just have one term with an x to the 4, so plus 15x to the 4, and I'm just crossing them off as I go. I've got two terms with an x to the 3, so I've got -2x to the 3 plus 30x to the 3, so that's a positive 28x to the 3. X squared, we've got two of them here. 3x squared plus 8x squared, that's 11x squared, if I combine those. We can combine these, 6x minus 12x, that's -6x. And then last I've got that plus 24, the one constant on the end. Whew, that was a long one. All right, so that's the end of our notes. If this was confusing to you, just come to class with questions and we will go over some together, and then you'll have some time to practice.